Hello students, good morning to all of you all. Assalamu alaikum. Welcome to the online session. So this is a day morning, holiday morning. I hope all of you all are fresh and ready. That's why I wanted to start at 9, not at 8, so that you all can have a rest and then start the session. So can you all hear me clearly and am I audible to all of you all? Can you all hear me clearly?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, good. So let's go into the discussion. Meanwhile, if any of your friends are having problems joining, tell them to. Again, I mean, like you go to that link and click it again, because earlier before I started the session, if they try to join, it will just show register. But now it's like register and directly join. So they can join now without any issues directly into the classroom. Hurry, let's go into the discussion. I think the recording also will be provided. So the ones who missed, don't worry. You'll be getting the recording. Okay, then Buddha, let's directly go into the session. Okay, so you all know the second lesson onwards, we are starting physics. If you take our O level, it is made out of two components, grade 10, grade 11. Grade 10 and grade 11. So when you look at the total of grade 10, grade 11, physics lessons are the highest. Totally we have 15 physics lessons. When you look at bio and chemistry, we have just 10 and 10. Totally we have 35 lessons for O level. Out of that, physics lessons are 15. So that means you will be coming across more and more physics topics. So out of that, one of the hardest one, that is the graph, because that is the one where we start our lesson. Actually, the first lesson for grade 10 is related to motion in straight line, where the graphs are introduced. So sometimes some students, they don't get a clear idea. So they used to complain, sir, we can't understand the graph in school. They taught many graphs. We don't know what that and this. So I'm going to make this graph lesson into a very simple, easy lesson, but I want your full concentration. Okay, please don't get distracted to that and this. Concentrate maximum, because I am going to talk to the point. I'm not going to, give notes and make you fill with notes. Okay, practically with the questions, I'm going to explain the graphs. So listen to me carefully. Whatever you have studied in school, even if you forget it now, no problem. That will be a great help, because when you learn the wrong thing or in the wrong way, it is very hard to put the right thing. But if you don't know anything, it's very easy. This is the thing here, I can give it to you. So first one, I am going to tell you the types of graphs in our syllabus. First, I will give you an overall idea, and then little by little, we'll be moving forward. Okay, so graphs under motion in straight line and situations. Buddha, there are just mainly three graphs. Okay, distance time graph, velocity or speed time graph. I'll use the word velocity time graph, and then acceleration time graph. So I'll be calling this dt, vt, at. Another dt, vt, at. dt means distance time graph, vt means velocity time graph, that can be also called as speed time graph, and at is acceleration time graph. Then look at the situations in our syllabus. There are 4 situations. First situation is object is at rest. So object at rest, you can draw these 3 graphs. But at last, I will show you all the 12 graphs in our syllabus. Okay, then you will understand at rest, we don't need to even draw graphs. Only for dt, we might need it. Other than that, these two, we don't need it. With questions, I'll be doing it, so don't worry. Then, constant speed, or we can call it uniform speed, constant velocity, uniform velocity. For that also, we have dt, vt, at. Then we have increasing speed. Can you tell me increasing speed or increasing velocity? Can you tell me another name to describe this?
Acceleration.
Increasing speed means, Monada,
Magnitude.
Acceleration.
what kind of a situation? The
Acceleration.
vehicle speed is increasing. Yes, it's an
Acceleration.
acceleration situation. Good. Acceleration situation. Then last one we have decreasing speed or decreasing velocity. That is known as deceleration, or in other words, we can call it retardation. Deceleration or retardations. These are the 4 situations: rest situation, constant speed situation, increasing speed situation, and decreasing speed situation. So for each we have these 3 graphs. So totally we will be having 12 graphs, right? So don't get scared. So should we memorize the 12 graphs? Don't need to memorize anything. Understand and do it. It's going to be very easy. Here also we have DT graph, VT graph, AT graph. DT graph, VT graph, AT graph. So now you'll have an overall idea that there are 3 types of graphs and we have 4 situations. So each situation will have all 3 graphs. So totally we have 12 graphs in our syllabus under motion in straight line. Any problems or doubts until whatever I have explained now? No. Okay, good. So now let's go to the first situation. Find the distance and displacement of the following situations. Okay, so I'm going to give it like A. This is a simple thing, okay? From A to B, a person moved. It is 10 meters. And then return from B to C, okay, which is, let's say, 2 meters. What about the distance from A to C? Displacement from A to C. Very simple Totta Baba question. Just a warm up for y'all. What is the answer, Puta?
Distance 12 meters, displacement 8
Sorry.
meters.
Can you all hear me clearly, Puta? Because I have been using that earphone. I have plugged the earphone. So now only I can.
Yes, sir.
Yes, sir.
Yes, sir, we can hear you.
Okay, Puta, good. So therefore, here, what is the answer, Puta? What about A to C?
Distance 12 meters, displacement 8 meters.
Distance is from A to B and then B to C, 12 meters. But displacement is always the starting point and the ending point, the shortest distance between the starting point and the ending point. So from A to C, it's this whole thing is 10, 10 minus 2, 10 minus 2, it is going to be 8 meters. But when you're writing the displacement, I think you can give an arrow and show something like this. You can show the direction. That's why displacement falls under vector quantity and distance fall under scalar quantity. What is the difference between scalar and vector?
No actual direction for scalar quantity.
Quantities don't have direction, vector quantities have direction in magnitude.
Yeah. The magnitude unit will be common to scalar vector. Only problem is direction. In scalar, we don't have a direction, exact direction we can't say, but vector, we can give one specific direction. Okay. Then let's go for a B question. A ball is thrown up. Okay. It goes 15 meters up and then comes back to the thrower's hand. Okay. So question is total distance of the ball, total displacement of ball. These like warm-up questions are very simple questions.
Distance is 30 and displacement is 0.
Yes, distance is going to be 30. Why? If the ball goes up 15 meters, when coming down, coming back to the hand also 15 meters, no? So obviously 15 plus 50, 30 meters. Good. Can we give a direction? No, it goes up in the first situation and comes down in the second situation, no? So we can't give a exact one direction. We can explain it in 2 directions, up and down, but we need one proper direction. So here this is not having that, so it's falling under distance, scalar quantity. And displacement, Puda, whenever it reaches the initial point, displacement is 0, then you don't need to even mention the unit. You don't need to even mention the direction because 0 is 0. You can't give a unit or a direction to 0. Are you clear about it?
Yes,
Yes,
sir.
sir.
Okay, good. Then let's go to another simple question. there is a semicircular ground. This is the track. Okay, let's say X and Y. A runner runs from X to Y, and they are telling you from the midpoint of the ground, towards the corner, the length is 14 meters. The length is 14 meters. Now they are telling you to find the distance which the sportsman or the runner covered when traveling from X to Y, and next they are telling you to find the displacement from X to Y. How are you going to do it? Distance
is 22 and displacement is 28.
Yes. How did we get the distance? Actually, it's a semicircular pathway, no? So
Arc length
yeah, from one point, from the midpoint to the corner, that is known as the radius. And this is the arc length. How to find the, like if you take the total circumference of the circle, in maths you have a equation 2 pi r. But here we don't need the 2 pi r because this is for full circle, no? I hope you all know this, but don't ask me what is pi. Okay, this is a maths equation. So then for half circle, we can use the half of it. For half circle, we can use 2 pi r divided by 2. Then this 2 and this 2 will get cancelled. We have to just put the value for pi and r. Pi is 22 over 7. Radius is 14. 7 and 14 will get cut. It will be 2. So final answer will be 22 into 2, 44 meters. That is the distance. Now are you clear about the answer?
Yes, sir.
Yeah.
Yes, sir.
Then displacement is from here to here, no? From this X point to Y point. So that means from here to the midpoint, it is 14. From the midpoint to the other side, it is 14 because it is the radius. Radius plus radius is the diameter. Actually, they are asking the diameter. So diameter is 14 plus 14, 28 meters. If anyone is having a doubt related to this, please ask.
Sir, can you explain how you got 44 meters again?
44 meters. Here,
For the
we need to find the length of this circular part. Normally in maths, for the whole circle, we call it total circumference. But here it's half. Do you know the equation to find the total circumference?
2 pi r squared.
Y squared, Buddha?
2 pi r. 2
pi r, no? So therefore, we have to use half of this. Not the full because we are using half circle. So into half and you will get the answer. That's what I have substituted, shown here and here. You can put the values. 2 into pi is 22 over 7. Yeah, someone is saying, so can we use 1.5 into 2 pi r? No, you have to use 0.5. Not 1.5, 0.5. Half is 0.5 in decimals. So maths, you can use any maths method. Okay, you can use any maths method, but you have to get the proper answer. So here radius is 14.
14.
And then we are dividing, multiplying it by half. Okay. So let's say this 2 and this 2 will get cut. This 7 and this 14 will get cut. Again 2 here. 2 into 2 is 44 meters.
I got it.
I hope you all are clear about it. Okay, let's move to the next one. Now only we are coming to a real graph type of question. Find the velocity of the car which started from rest and moved at a constant velocity. So this situation is going to be what situation? Constant velocity situation. And reached 80 meters within 20 seconds. So that means there was a car. Then it started moving with the same speed. And it covered 80 meters Okay, that is the distance or displacement. The time taken will be 20 seconds. Is it hard for you to find the velocity? No. Very simply, you can say velocity equals displacement divided by the time. Displacement divided by the time. Here, they are not telling that the car has moved, returned back, something like that. So therefore, directly the distance will be the displacement in this situation. So distance is 80 meters. Time taken is 20 seconds. 0 and 0 will get cut. 8 divided by 2 will be 4. And unit will be meters per second, because when the S comes up, when the denominator is trying to become the numerator, the powers will be either minus or plus. If it is plus, it will become minus. Minus will become plus. So that's why this went up. It became S to the power minus 1. So already we have done this in the theory part also. This is the basic one. Now, if they tell you to draw the graph, you can draw two graphs for this situation. First one is distance time graph. Other one is velocity time graph. The easiest one to draw here is velocity. Always velocity time graph is the best. If they tell you to find the distance time graph, directly you can find it. But if they tell you to find distance time graph, velocity time graph like that, first go with the velocity time graph. Shall we draw the velocity time graph for this? Look at this carefully. Okay, in physics, whenever you are drawing the graph, you have to put the, like maths, you have to put the coordinate and you have to put the symbols. This is going to be a velocity. Units should be put in brackets, ms minus 1, versus time graph. Time is in seconds. You don't need to mark each and every point. You have to write the starting point and the ending point. According to time, starting at 0 seconds and ending at 20 seconds. Then for the velocity, we have found the value 4. So we can say if this is 2 and let's say this is 4. Now tell me, Putha, they are telling you the vehicle started from rest and moved at a constant velocity. Has the velocity increased, decreased, or the same throughout?
Same throughout, sir.
Same throughout.
It's same throughout. So that means from 0 time to the 20th minute, 20th second, until the 20th second, the graph is like this. Starting also 4 ms minus 1, ending also 4 ms minus 1. So it's a straight line graph like this. Remember, wherever, if you get a constant velocity or constant speed, uniform velocity, uniform speed, this is going to be the shape of the graph. Now here for this question, we have put the values, but basically we can understand the shape of the graph. We don't write the whole second. We can write the last time. Yes, Putha. Don't worry. In physics, you don't need, like maths, you don't need to mark one by one. You need to mark the starting, ending. And in the middle, if they have said at 5 seconds this happened, at another 5 seconds, then those points you have to mark. Other than that, you don't need to mark each and everything. Putha, can you all hear me clearly?
Yes, sir.
Yes, sir.
Okay.
So is that one in this graph?
Yeah, give me another 1 minute. I will explain. Yakub, Putha, I think accidentally, wait, this annotation is there, no? I'll remove it. Okay. Then some students are confused. So it's starting from 0 now. The distance is starting from 0, not the velocity. Because this is always constant velocity. From the starting point, it is maintaining the same velocity. If you are drawing a distance time graph for this question, so I'll draw a distance time graph. Then you will understand this is the distance or displacement. Both are almost same. I told you earlier when teaching, they will tell you distance and displacement are totally two different things. But when it comes to graph, distance value will be the displacement value. So look at the time. Starting from 0, ending at 20. Distance. The car was in the starting point. 0 distance. Ending distance is 80 meters. So starting main point was here. Distance time graph. Ending point is here. So distance time graph or displacement time graph will be like this. Then again, I will draw you the velocity time graph and show it to you. Velocity time graph. VT graph. Velocity is meters per second. Time is in seconds. So 20 seconds, 0 seconds. But the velocity from starting, they are saying it is 4 ms minus 1. So starting also 4 ms minus 1. Constant velocity. Ending also 4 ms minus 1. So therefore, this is the velocity time graph. So now keep in mind, whenever you get a constant velocity or constant speed situation, distance time graph will be increasing like this. Velocity time graph will be constant. Does this have an acceleration? Question. In this situation, do we have any acceleration?
No, sir.
No, because look at the velocity time graph. Same. If the velocity time graph goes like this, it is acceleration. If the velocity time graph comes like this, deceleration. But we don't have any acceleration, deceleration here. So constant velocity means 0 acceleration. So do we have acceleration time graph for this? No, it's a 0. So there is no graph. So remember, whenever you get constant velocity, constant speed situation, there is only two possible graphs, distance time graph and velocity time graph. Did you understand this clearly? If you have any doubts, please ask. Others quickly copy the question and the answer, and I'll show you the next slide, then you can copy the graph.
Excuse me, sir.
Yes.
Sir, then if we get the different speed, we can get DT, VT, and also AT, right?
Yeah, when the speed is increasing or decreasing, all three graphs are available. Our upcoming questions will be related to that.
Okay, sir.
Excuse me, sir. Should we write this on the tube?
Yeah, the ones who have the tute, the ones who are coming to my classes, you would have got the tute. You all can start writing in the tute. The newcomers, yes, just raise the hand. Anyone who is totally new to this lesson? I mean, new to my classes. You're not there in my any paid classes, physical law, online or anything. First time you have come here? Anyone? Okay, there are a few students. No, so those students, you all can write it in your writing book or take some papers and write it, because this whole graph thing you can document it into one set of papers with today's session. Yeah, if any 11.5 students are there, just listen and wait relaxedly. You all don't need to write. This is for the next week O-level students, huh? One or two have come. So you all can relaxedly listen to this. If you find that any graph is important, then draw that graph.
So we have to draw this in the tube.
Yeah, there are some empty pages, no? Page number 4, 5, 6 and all. In those places you can draw it. Yeah, draw this question and draw the answer. From next question onwards, you all take a screenshot. Then later after the class, you all can draw. Then we can save time to do more questions. Okay, for now, the ones who don't have the tute, take a book and start writing it. Don't waste the time. Quickly write. Then I will show you the graph. Okay, don't need to put any designs or anything, just roughly draw the graph. Here the main thing is understanding, not writing it beautifully, understanding it. Because once you understand, you can do any question. But if you make designs and draw, but if you don't understand, no use of this session. And don't worry about that, I will put each and every graph in the WhatsApp group. The ones who want to take a screenshot, quickly take it. We can move to the next question. Take a screenshot. All the graphs, all the writings will be uploaded to the group. So don't worry. The ones who missed writing, don't worry. I'll be uploading it in the group. The other thing is the ones who are not there in the group, send me your name, grade, school. If you all are online students, just put online. If you all are already coming to Brightex, put Brightex. But I think all of the Brightex students are in the group. And if you all are from Master Academy Kolonava, put Master Academy. Then I can add you to the respective groups. But online students, I will add you to the online group. All the other students will be added to the online group. The ones who are coming to my classes, the ones who are not coming to my classes, no problem. All of them will be added to online. So you all can send your name, grade, school. Then it is to my WhatsApp number. Here my number is there in the bottom part. Then I can add you. Later on, I will add you. And then after that, I will upload all the. And also this recording will be there in YouTube also. So you all can share it to your friends. That is one help I want from your side. I want you all to share this maximum because many students are struggling with this graph lesson. Okay, take a screenshot of this also. Later on, nicely you all can draw. Especially the girls, they want to use 2-3 different colors of pens and all those things to draw it beautifully. So you all can take your own time and draw it. But now, today's session, understanding. You understand the graphs. That's the main thing. Okay, then we'll go to a situation where acceleration situation. So here, the object which started from rest, that means distance is also 0, and reached a velocity of 60 ms minus 1 within 3 seconds. Here, Puta, you can understand velocity is also 0, distance is also 0, velocity is also increasing, distance is also increasing. Obviously, when the vehicle is moving, distance will increase. Okay, distance will increase now. However, when the object is moving, even if the object is moving with uniform velocity, distance will increase. Even if it is going with increasing velocity, then also distance will increase. Even if it is reducing velocity, then also distance will increase. Always the vehicle is keep on moving, so distance will increase. So Balanna, find the acceleration of an object which started from rest. Rest means initial velocity is 0 and reached a velocity of, that is final velocity, 60 within 3 seconds. These are the datas. You all can underline whenever you get a question like this, you underline the data or highlight the data, or separately you can write initial velocity 0, final velocity 60, time is 3. Like that you can write the data in a place and keep. Then it is easy for you. You don't need to read the question again and again. Once or twice you read it, understand it, then go for the answers. So here they are telling you to find the acceleration. Okay, it's easy. Can someone tell me what is the equation for acceleration in our syllabus? A equals
Velocity times
Initial velocity
minus final velocity.
Okay.
Okay.
By time.
Actually, it is like this, huh? A equals
Final velocity
V minus U over T. It should be first final velocity minus initial velocity divided by time. This is the only equation. You don't have a separate equation for deceleration, separate equation for retardation. No, only acceleration equation. Then even for the deceleration situation, are we going to use this? Yes, and we are going to get a negative answer. Understood? So in this situation, acceleration equals final velocity minus initial velocity. Very clearly, when you open your eyes, you can see the final velocity is 60. Initial velocity is 0 and the time taken is 3. Okay. Then acceleration equals 60 minus 0 is 60. 60 divided by 3 is 20 ms minus 2. Because why did this ms minus 2 come? Already you have velocity ms minus 1. We are going to divide that by 3 seconds. Then again this s will go up. If this s goes up, it will become like ms minus 1, s minus 1. When you join both together, according to maths, the powers will be added ms minus 2. That is how we got the velocity unit. If you don't know how to derive, just memorize it. Because we have only few, no? For distance, we are using meters. For speed and velocity, we are using ms minus 1. For acceleration, deceleration, we are using ms minus 2. Those are the main three. Distance, everyone knows. Velocity also, you all know. If you are confused with acceleration, just memorize it. Okay, then according to this situation, the acceleration is 20. According to this question, only that much. But I want you all to focus on the graph. So here you can draw the distance time graph, velocity time graph, and acceleration time graph. I'm going to show you all this. This is the most important thing. So you can take a screenshot of this. Okay, and then we'll move to the graph. Three graphs are there. Three graphs are there. Keep the values in mind. What are the values? Initial velocity 0, final velocity 60, time is 30. Sorry, time is 3 seconds. Now we did the calculation and found the acceleration. It is 20 ms minus 2. Now we'll go to the graph. I'm going to show all three graphs. So listen carefully. dt, vt, and at. Okay, now I don't know. Now some students will start crying and say, so our school teacher said there is no acceleration time graph. Our school teacher said there is no curved graph. Puta, directly in the syllabus it is not there, but O-level questions they are asking. So we need to learn it. Okay, we need to learn it. Just by memorizing the textbook, you can't get the marks. Practical understanding should be there. So practical questions have been given in the past papers where curved graphs are available in our syllabus. Okay, so no complaints, just study. Okay, so I always tell you the easiest graph to draw is the velocity time graph. So according to the situation, starting time is 0, ending time is just 3 seconds. Okay, starting velocity in this situation, it's not constant velocity, increasing velocity. From what to what has it increased? From 0 it has increased to 20. From 0 it has increased to 20. Here we'll put the units ms minus 1. Here we'll put the units time. So there are two main points here. Starting point 0 distance. Sorry, not distance. We are not talking about distance. 0 velocity and 0 time. Ending velocity 20 ms minus 1. Ending time 3. Are you clear? We plotted the 2 points now. Just connect it. So whenever you get an acceleration situation, velocity time graph shape will be like this. Okay, that is the final thing I want you all to understand. Finally, I will draw all 12 graphs and show it to you. Then you will be more 100% clear. Whenever it is a acceleration situation, velocity goes up. Then what about the acceleration? At 3 seconds, 0 seconds to 3 seconds. Okay, increasing velocity means constant acceleration. Here we found the acceleration value as 20, no? 20. It's a constant acceleration. Starting acceleration, ending acceleration. Constant acceleration. So I can mention this as increasing velocity means constant acceleration. In our syllabus, under acceleration, we have only constant. We don't have increasing or decreasing acceleration. So you don't need to worry. Whenever, if they give acceleration time graph, it will always be like this, or zero graph, or something like this. The shape. Yes, very good. How to find the distance in this situation? They have not given it. Okay, now you might say, sir, we can use speed equals distance over time, then distance equals speed into time. Yes, you can use this, but not for acceleration, deceleration situation. This is the place where many teachers make a mistake. They say anything you can find by using distance, speed into time. No, no, no. In the previous situation, it would have been okay, but now, no. Okay, in the uniform velocity, okay, but acceleration, deceleration, you can't use that. So always, if it is an acceleration related question, deceleration related question, keep this in mind. Graph area under the velocity time graph will give you the distance. This is applicable for any situation. So that's why I'm always emphasizing my students to go for the area under the VT graph will give you what? Distance. Area under the DT graph. So what is the area under this graph? How do you find it? What is the equation? It's a triangle, no?
Divide by half.
Into base
Half
into
into
perpendicular height.
base into height, yes. Half is half. Base ki other 3. Height can take this as the height. 20. So 2 and 20 will get cut. 10 into 3 is 30 meters. But if you are doing in the normal method, you're thinking that this one can be done by distance equals speed into time. You will take the initial or final speed, it will be 20, and then multiplied by 3, it is 60. That is wrong. Okay, because this is not a constant speed, no? Little by little, the speed is increasing. So you can't use this distance equals speed into time. That can be used only in constant speed or constant velocity situation, not in acceleration situation. Are you clear about it? Then Puta, how are you going to draw the graph for distance time graph? You found out that at the end of the 3rd second, the distance is key. By calculation, we found 30 meters. Then we'll mark that point. This is very important. And starting, the object was in one place, 0 time, 0 distance. How are you going to mark it? Not like this, not like that. Whenever it is an acceleration situation, distance time graph will be slightly curved like this. It will be slightly curved. You might ask me, sir, this is not there in the textbook, but O-level past papers, they have given it. Again, in grade 11, you are not going to learn this. Only in grade 10, unit 2. So this distance time graph for acceleration situations are there. You should know it. Very simple. Acceleration situation, it will be curved this way. Deceleration situation, it will be curved this way. Next, I will be teaching that. Okay, for now, did you understand
Yeah, sir, crystal clear.
So practically, why does it look like that?
That is because what is happening when the velocity is increasing, the car is not traveling like now. For example, for first second it will travel 10 meters. Then you mark it like this. First second 10. Then second it will travel not 10, about 30. Then third second it will travel about 40, and like that it increases like this, drastic increasing. Because the vehicle is accelerating, the driver is pressing the accelerator, so the vehicle tries to go fast. That means more distance is covered than the earlier stages. So the distance graph is always curved for acceleration deceleration situation. Now earlier we studied uniform velocity. No, if the velocity time graph is like this, then distance is constantly increasing. Every second 10 meters is increasing. Another 10, another 10, another 10, another 10. But now we studied what is happening. 10, then next second 20, next second 40, next second 80, 100. Distance is also drastically increasing. Yes, take a screenshot of this, Buddha. Next. Buddha, I will give you 2 minutes. Try to understand this. More than writing, try to understand this. If you get any doubts, please tell me. I will explain.
So what does the increasing velocity equals constant acceleration mean?
That means that is the situation. Whenever velocity increases, what is that? What is happening to the vehicle? Acceleration. Yes, then someone has asked how to find the displacement here. Here, the same way you found the distance. The area here, I have put area under the velocity time graph will give you the distance that is equal to the displacement. Here they have not spoken about the vehicle returning or anything. No. So in all the graph related questions, distance will be equal to displacement. 99% it's like that. Shall we do one more question like this?
Okay, sir.
Good.
Okay, sir.
We'll go for a deceleration situation. Find the deceleration of an object which was traveling at a speed of 90 ms minus 1 and came to rest after 3 seconds. What are the data? This is a what situation? Deceleration situation. They have told us. If they have not mentioned how to identify the speed, initial speed or initial velocity is 90 ms minus 1 and came to a rest. That means final velocity is 0 ms minus 1 after 3 seconds. So now you know this is a deceleration situation. Here one thing they have mentioned it. Even if they don't mention, you can see they have said they have given the values. Speed was 90. After that it came to a rest. Rest means stopping, no, 0. So velocity will become 0. This is not a constant speed situation. You can see very clearly they have told you that it is reducing. So reducing speed or reducing velocity is equal to what?
Deceleration.
Deceleration. reducing speed or reducing velocity means deceleration. Okay, in our syllabus, do we have a special equation to find the deceleration directly? Sometimes teachers who are teaching London syllabus, they might tell you initial velocity minus, we are using initial velocity minus final velocity, no. Sorry, final velocity minus initial velocity, no. They will change the equation and tell you that is the deceleration equation. Maybe in London syllabus it is there, but in our local syllabus, we are only using A equals V minus U over T. Then acceleration, even for deceleration situation, we are going to use the acceleration equation. What is the final velocity? Object came to a rest, so 0. What is the initial velocity? Started at 90 ms minus 1. What is the time taken for this? 3 seconds. So answer will be 0 minus 90 is minus 90. Divide by 3. Answer is minus 30 ms minus 2. Why did we get a minus answer here?
Deceleration.
Yeah, the situation is deceleration, but we are using the equation, acceleration equation. So finally you do like this and get the minus answer, and then in wordings you have to put deceleration, or in our syllabus they use another word, retardation, and now you can put the positive value, 30 ms minus 2. Wordings are correct, no? Here until this point you use the acceleration wording, acceleration equation. So until that you got minus 30. And then you totally turn the word into deceleration and got the proper answer. So this is how you do a question which is having reducing velocity or reducing speed. In those situations, if they tell you to find the deceleration, you use the acceleration equation and come until the last point, and then finally you convert it into positive answers. Are you clear? Now what are we going to do? We are going to draw the distance time graph, velocity time graph, and acceleration time graph. But you can tell me, sir, this is a deceleration situation. Can't we draw a deceleration time graph? That is not there. So we have to draw acceleration time graph. So tell me here also, what will be the thing? It will be a minus type of graph, no?
ms minus 2.
Yeah, acceleration is ms minus 2, but this situation is a deceleration situation, but we are going to plot an acceleration time graph. So most probably it will be a minus value. Okay, when doing the graph, I will explain it to you. Yeah, now Puta, read the question properly. Check how we found the acceleration and then how we converted into deceleration. If you have any doubts, please ask. Then we can go for the graphs.
So when you get deceleration, isn't it minus 30?
No, Puta, because until you're using the word acceleration, we got minus 30. But now what we have done, we have put the real situation. If acceleration is minus 30, that means deceleration is 30. So actually they're asking the deceleration now. So we have to finally give the deceleration real value 30. Okay, shall we go to the graphs? So now before going to the graph, the data are important. So you have to write it separately and keep initial velocity 90, final velocity 0, time taken is 3, and now we have found the acceleration value, that is minus 30. Keep that also in mind. Now we'll go to the graphs. Distance time graph. Velocity ms minus 1 time graph. Or speed time graph, same thing. Then acceleration ms minus 2 time graph. But here, obviously, you all know, because now, yeah, for the new students, I'm telling you, for my students, I have already scolded them. Remove your grade 9 mentality totally, and grade 10 understanding is the most important thing, because in grade 9 you depend on memorizing, mainly on memorizing. Once the teacher says something, you memorize it and you vomit it in the exam, you get good marks. But 10 and 11, economy, especially in 10 and 11, you understand it, because in the exam, every situation is going to be new, total new situations. So by just memorizing the physics and chemistry, you can't get the answer. You have to know the method and apply that to the new values they have given. So now, even now, I am telling you, don't just memorize the values. Okay, learn the pattern of the graph. How did the graph come? If you know how the graph comes, then you can do any question. So always start with what graph? Which one is the easiest, Buddha? I want your answer.
Velocity.
Velocity time graph.
Velocity time graph is easy. So let's start it that. So I'll write the data here. Initial velocity was 90. Final velocity 0. Time taken is 3 seconds. Acceleration is minus 30. Why did we get minus 30 acceleration? Because this is deceleration situation. So velocity time graph at 0 time. 0 time, what was the velocity of the vehicle? 90, no? Initial velocity 90. At the end of the time, at the end of 3 seconds, what was the final velocity?
0.
0. Starting point here, ending point here. Just join it. Straight line, huh? Then what about the acceleration situation? From the starting to the end, the car has reduced the speed. No, that means, let's say, when the car was traveling, okay, he was traveling at 90 ms minus 1. Sorry, 90 ms minus 1. He saw a cat crossing, black cat crossing. Already when the cat crosses, it's very hard to drive. And if the black cat cross, according to Sri Lankan culture, we have something, no? If the black cat cross finished, your day is going to be, I don't know how scientifically you're going to explain the black cat and this situation. So the driver will apply the brake, no? Within 3 seconds, he will stop. So obviously, you all know this is a deceleration situation. Okay. So here they have given acceleration time graph. In our syllabus, we have only acceleration time graph. But if you want to show the deceleration, you have to show minus 30. And the time is 3. So from the 90-second onwards, the brake has been applied. That means deceleration is constant deceleration. I told you, in acceleration, we don't have upwards, downwards. We just have straight line. And also, Buddha, this minus 1 is not there in our syllabus. But I told you, I'm teaching it to you because it is very easy, not a hard thing. Earlier, it was acceleration situation. We got a positive acceleration time graph. Now it's a deceleration situation. So we got a negative value. If you can't understand this, no problem. No issues. We don't have this in the syllabus, but I just told you. How did I get the value? I did the calculation and got the value. I did the calculation and got the value. Okay, now distance time graph for deceleration situation, it is there. Is it there in our syllabus? Yes, yes, yes. It is there. But will the school teachers teach? Only a very few will teach. Okay, honestly tell me, the ones who have covered this lesson in school, okay, tell me how many of your teachers explained about this curve graph? If they have explained, it is really good.
Explained but didn't understand.
Explained, didn't understand. That is normal for all the lessons. Okay, Afana. What about any others? You're from Kolanava Balika, no?
Yes, sir.
Any other schools where they didn't explain it all at all but completed this lesson? Some schools they have not started the lesson yet. Okay, no problem. Then you will, when completing it, you will be able to notice whether they are teaching it or not. Okay, now come to the distance time. This is only important one. First we have to find the distance. No, you don't have any other method to find. There is a method. Your school teachers will say final velocity plus initial velocity divided by 2. Yeah, past paper question we explained, no? What is who made the Hanafi? What is the message? So is distance time and ST graph same? No, no, Buddha. DT means distance time. Now, what is your S? Speed time graph is totally different. Speed is like velocity. Hurry. So always, my students, I'm telling you, trust me. Whenever they tell you to find the distance in graph related questions, always go to VT graph. Actually, the easiest graph to draw is velocity time graph, and from the velocity time graph, you can get a lot of data. Area of this velocity time graph will give you the distance. Keep that in mind. Keep that in mind. So area under this graph, half into base into height. Half is half. Here the base 3. This is the base from here to here. The height is from here to here. 90. So 45 into 3. Here 135 meters.
135.
Correct, no? So we found the distance value. So will the distance and displacement always be equal in graph questions? Yes, 99% of the time, distance value will be same for displacement in the graph questions. Because in graph questions, the ball is returning back like that. They can't give, no? The vehicle is returning back. So therefore, whenever the graph questions are given, distance is almost equal to displacement. Because all are in straight line. Hurry. Then Puta, how are we going to draw the graph? First starting situation, 0 time, 0 distance have moved. By the end of 3 seconds, by calculation, we know it has moved 135. We'll put the ending point also. So starting point, ending point, we got it. But here, you know, what is this situation? I want to hear it from you all. What type of situation?
Deceleration.
Deceleration situation. Whenever deceleration or acceleration, it should be a curved graph. Acceleration curve will be like this. Deceleration curve will be like this. So what I'm going to do is, this is a deceleration situation. Curve will be like this. Okay. In the middle, how do we get it? You don't need it. This is not maths. This is physics. So you need only the starting point, ending point, and I'm telling you the graph is curved. So keep in mind acceleration, deceleration graphs are curved. So you can draw it like this. Yes. I'll give you 2 minutes to understand it. Whenever you come across any doubts, please ask. I'll send the screenshot. Meanwhile, you all can take a screenshot. I will send the screenshot in the group also.
So will you teach this for physical class students again?
Yeah, I'll be doing questions related to this. But now it's your time to, maximum understand this. Because in schools, when they do this, you all can do these methods and get the answer. School teacher will be shocked. So school teacher shocked, students rock. Because when you go with a lot of notes for this, you forget the main thing. So that's why I'm purely going with graphs. How to find the distance in curve graph? You don't need to find the distance in curve graph. always you have to find area for what graph? Velocity time graph. So velocity time, we don't get curved in our syllabus. So we are happy. In A level, they will give you the method. You have to find the area of the sector. But O level, either it's a triangle or a rectangle or a trapezium. That's all. We'll go to a trapezium question later. I will do that. Trapezium related question. Yeah, basically now you all know the main four situations. Yeah, take 1 more minute and try to understand. If you have any doubts, please send it through message. Okay. Yeah, before going to that. Can you acceleration be Sinhala dala tiyena? I can't understand Sinhala, right? In English and said. So why are we using U and V for initial and final velocity? That is the standard symbol. Normally velocity is V, but if there is a situation, there is a starting and ending velocity. Starting velocity is initial velocity U, ending velocity is final velocity V. So from the alphabet only they got U, V, W, X, Y, Z. So U is starting, V is ending. Ehema. So in the we have a class Sunday grade 10. This week we don't have class. Online class is not there. Online class, physical class. Okay. Because first and second, I am having this our Colombo seminar. Tomorrow I am having Candy seminar. Yeah, now I think we are my online classes. I'll just explain this because one student asked the timing. Online classes, we are back to normal because our from next month our 2024 batch is not there. No, they were the trouble in the middle. No, because of that I had to change all the timings. So now they are gone. Next week onwards, their exam is starting. So we pray for their good results. Okay, from this is for online students. Sunday 8 to 10 we will be having grade 11, 10 to 12 we will be having grade 9, and 12 to 130, sorry, this is grade 10, 12 to 130 grade 9. So just take a screenshot of this. For online students, this is 1800, this is 1600, and this is 1400. The grade 11 students, you all will be able to get the grade 10 classes also revision. Full syllabus, you will be able to get it. So don't worry. The ones who missed the grade 10, grade 1, now you all are in grade 11, now you all will be getting grade 10 also. You all can inform me, then I will be giving you. Ayo, this 2024 batch is still here inside also. They are there, no? No. That was a super batch, okay? Because when I was starting that batch, I was in my intern, my full rush schedule. Because 1 year I had to work with the government. Okay, that is full rush schedule. 24 hours we had to be in the hospital and all. So therefore, at that time, I used to, cancel a lot of classes, reschedule, but they were still with me. So that is a very good, obedient bench. But their work is done. Now I am not scared about them. Okay. But now my main target is the new grade 10 and 11, 2026, 2025 bench. Okay. So this is my timing. So this, I think from the 9th onwards we'll be starting, no? March 9th, this time we'll start because 2nd I am giving a holiday. From 9th onward it is starting. So anyone who wants to join the class, you can send me a message. I will add you to the group. and all the updates will be given in the group. Okay. Yeah, and I want you all to share the message because many students, many students, yeah, online seminar and all, you send me a message, I will edit it. I will send it. Many students, they don't have a proper guidance for science. So don't worry, whether you are my online or physical students, you will be getting the full, real, detailed explanation for science so that you understand science properly. Then we'll go to the summary of these things. Yeah. Balanna, now look at this. Resting situation, rest situation. We'll draw that last. Then next one is constant velocity. We can say constant speed also. Do we have any acceleration in this situation? Constant velocity, keep in mind, acceleration is 0, no acceleration. Yeah, the ones who came late, you can watch the recording, no issues. Then, so this is A situation, B situation, C situation, and D situation. C situation is going to be increasing velocity. Another name for that?
Acceleration.
Acceleration. D situation is decreasing velocity. Two other names for that?
Deceleration and
Retardation.
Retardation.
Deceleration and, very good, retardation. Yeah. Now we are going to draw the dt graph, vt graph, and at graph. Here also dt, vt, at. Here also dt, vt, and at. Here also dt, vt, at. So you all know the pattern of dt, vt, at. Okay, these are the 12 graphs in your syllabus. I'm going to explain one by one. Already with questions we have explained. Now we are going to finally summarize this. So Puta, look at your first question which I gave you related to these graphs. The vehicle is moving with a constant velocity. In that situation, the velocity is constant, no change like this. What about the distance time graph? Like this. No curved graph, straight line. Do we have an acceleration for that situation? Acceleration is 0. No acceleration. When the vehicle is going with the same speed, it is not acceleration. Some students think speed is only acceleration. When there is speed, there is acceleration. No. Constant speed, no acceleration. Only for increasing speed, we have an acceleration. For decreasing speed, we have a deceleration. So keep that in mind. Then next one, Puta. Increasing velocity situation. What is happening to the velocity? It is increasing. Velocity increases. The second graph question which we described. A car traveling at 60 0, car starting from rest 10, reaching 60 ms minus 1 within 3 seconds. That one. There we had a constant acceleration, no? AT graph was like this. The value was 20. Now I am not putting any value just to give you the shapes of the graph. Then how was our DT graph, Puta? Was it a straight line graph?
Curved.
curved graph. Curved.
We found the final distance by finding the area and then we just curved it. If you want to memorize, just memorize that part. You find the total distance. How did you find the total distance? By finding the area under the graph, and then we plotted that point and we put a curve. Then last situation, deceleration situation, velocity time, velocity reduced. Acceleration time graph, it's not an acceleration situation, it's a deceleration situation. So we got a minus answer like this. Okay, then what about the distance covered? We found the distance by finding the area. But when drawing the graph, did we draw a straight line graph? No, we drew a curved graph like this. Yes. Now we'll go to the rest situation. An object is at rest, it is not moving. Will it have an acceleration? No.
No.
Will it have a velocity?
No, sir.
No.
Will it have a distance?
No, sir.
But
No.
there can be one situation where already the object has moved and then stopped. Those situation, from the point where it stopped, it is like this. Okay. From the place it is stopped. It depends on the situation. So these are the 12 graphs present in your syllabus.
Excuse me, sir.
Yeah.
For the rest one, where there's a distance time graph,
Hmm.
if it's at rest, the distance is zero, ne?
Yeah.
So
So
you
that's
don't
why,
have to do anything.
yeah,
Just
here
keep the
it is zero situation also can be there. But in certain questions, it comes like this. The object moved 10 meters and then stopped. There, moving 10 meters will be shown like this. Stop situation will be shown like this. So that stop situation only I have given here. Okay, there can be a possibility where it has already moved. So number one graph,
If it's zero, we can just keep it without writing.
without writing. No graph, if it is zero, you can just keep it without writing. Number 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. These are the 12 graphs in our syllabus. We'll take a screenshot. And now I'll tell you out of this, what are the unwanted graphs? Drawing an acceleration time graph for deceleration situation, it will never be asked because it's a minus graph, they will not ask. Then, obviously, when the object is at rest, do we have a velocity? No velocity at all, no. So that graph they won't ask. No use. Zero graphs, asking you zero graphs is useless, no. If there is no velocity, will there be any acceleration? That is like moda katha, ne? Like one person is blind. Okay. Can you ask a blind person? He can't read, but can he differentiate colors? Ado. Pain නැත්තම් කොහොමද බං color බලන්නේ? Read කරන්නේ අන්න something like that, no? When there is no velocity, then how can we get an acceleration? It's like a moda question, no? Asking acceleration for a rest situation. So therefore, see, only this much graphs are there. I have cut all the unwanted graphs. Out of that, the most important ones are these two and these few. Okay, so now take a screenshot. This is the summary of today's lesson. All the main 12 graphs. Any other questions is related to these graphs only. Yes. Take a screenshot of this.
Velocity.
Yes, all your doubts ask now.
Sir, what is velocity?
What is velocity? Yes. Huda, I think you will have to watch the recording again because velocity means it is the change in the distance. Distance or displacement divided by time. The exact equation is displacement divided by time. Something similar to velocity, we have something known as speed. Okay, it is distance divided by time. Speed and velocity are almost same thing. Okay, almost same thing. Only one difference. Speed doesn't have an exact direction. Velocity has an exact direction. Yes. Next question. Watch the recording. The one who asked, I have explained clearly from the first question. So isn't it necessary to write that table, that Cartesian plane? No, you don't need. O-level wise, they don't give. But in schools, to explain to you this, they will give you at the first second it was 10, 20, at the second it is 40. Okay, that is not there for the O-level questions. That is just for the explanation sake. But that is for a grade 9 or grade 8 student, that explanation is okay. But I think a grade 10, 11 student will understand from the starting point, ending point. So decreasing acceleration, in that I didn't understand the distance time graph. Nothing to understand. Okay. In any situation, acceleration situation, you can find the total distance. Now you mark it. And when putting the graph, you curve it towards the downwards. Then this 11th graph is decreasing velocity graph. There also you find the total distance by finding the area, put the dot and draw the graph little bit curved upwards. They are nothing to understand, just okay, just the curved side, you should remember the curved side. So in the grade 10 exam, how will they ask the question? Like how we started the question? An object was moving from 90 meters and then stopped. From there, they can start the question and one by one they can ask. Draw the distance time graph, draw the velocity time graph, or they will give the graph and ask which graph is corresponding to this. So when you understand the concept properly, anyhow they give you the question, you will be able to answer it. Are you clear about it?
Yes, sir.
Yes. Then now I'll erase this. The screen will go away. So quickly take a screenshot. Anyways, I will be putting all the screenshots in the group also, so that the ones who don't get the recording will be there. Now this one is a free seminar, no? So I'll be putting it in the YouTube. So a YouTube you can watch it. My YouTube channel is Science Academy Colombo. Or when you type Rihan Raheem Science Killer, all my videos will come. Okay. Then Puta, I'll just explain to you the distance time graph again, because some students were having the problem with the curved graphs. No. So for the first situation, I will explain with this white color, rest. So can you tell OL target questions for this batch 2024? For them in our final seminar, we will target something. Resting situation is either like this or like this. Okay. Normal resting means it is 0. If it is already moved and rested, then it will be starting from 1 point. Then second situation, I'll explain in yellow color. Second one, in a constant velocity situation, constant velocity, how will be the distance time graph? Something like this. Constant velocity situation. Increasing velocity. What type of a graph?
Curve.
Curved.
Curved like this, no? Then decreasing. Curved from the other side. These are the possible graphs for distance time graph. This is the only confusing part, no? Why it is curved? Okay, there is a more explanation for that, but it's A-level explanation. So what you should know is starting is 0, find the final distance. If it is acceleration situation, that means increasing velocity is acceleration. Acceleration, the curve will be coming from down and then going up. If it is deceleration, the curve will be going from up and then coming down. But no acceleration situation, that is known as constant velocity. Constant velocity. Are you clear about all the three things I have shown in a distance time graph. 4 situations. Rest is also shown.
Yeah,
The
yeah,
situation,
sir.
constant velocity, acceleration, deceleration. I think if school teachers also give a final summary like this, you will never forget it. But the problem is they are just reading and you keep on writing. The final summary part they tell you to do, but you all don't know how to do. So now what I have done is I gave you the 12 graphs final summary, and then now distance time graph I have given like this. Take a screenshot of this. Then like this shall we do for velocity time also? Yeah, velocity time. Velocity time. First situation is rest. Do we have a velocity time graph for rest? No, it's a zero graph, so we don't need to care about that. Then second situation is constant velocity. So obviously this is velocity time graph. If it is constant velocity, it will be like this. Then next situation, increasing velocity. How did it go? Either from 0 it can go up, or from here it can go up. That means if there is an initial velocity, then from here it will go up. So for now, you just remember this today. Can you tell me another name for increasing velocity?
Acceleration.
Acceleration.
Acceleration. Then Puta, decreasing velocity will be
Deceleration.
yes, the graph will be something like this. Are you clear about this?
Yes, sir.
These are the only possible graphs related to velocity time in your syllabus. Then last one, acceleration time graph. You have only two situations. One is during acceleration situation, other one is deceleration situation. Shall we draw that also?
Yeah, sir. Okay, sir.
Okay, good. Acceleration time graph. In our syllabus, we have only, constant velocity means no acceleration. Constant velocity doesn't have acceleration. Zero constant velocity. Then next one, if it is increasing velocity, it's a acceleration situation. Acceleration graph will be like this. Positive value, I'll just put X. If it's a decreasing velocity, then obviously we are going to draw a decreasing velocity deceleration situation in what? In an acceleration time graph, the graph will be minus. These are the only possible one. Deceleration. This is acceleration. These are the only possible graphs for acceleration time graph, and I told you this deceleration won't come for O level. Minus graph won't come. Clear about this? Take a screenshot. And finally, we'll do one more last question for the day. Yes. An object was thrown down from a tall building with a velocity of 20 ms minus 1 and took 10 seconds to reach the bottom. Find the height of the building. Here I'll give you one data. Gravitational acceleration is 10 ms minus 2. This is the gravitational acceleration. So if you are drawing the situation, or always in physics, if you get a question, either put
So isn't it 4 seconds?
Puta?
So isn't it 4 seconds?
Yeah, 4 seconds, and took 4 seconds. Acceleration due to the gravity is always 10 ms minus 2. So that means, let's say you're climbing on the building and waiting until your enemy comes. Okay. And you're taking a stone and you're not dropping it. Dropping means you just leave the hand. Then it will start with the initial velocity 0. But now you're so angry with your school principal. Oh, not good to say principal, no? You're so angry with your enemy, someone, you name him. Okay. You're throwing the stone. See, such a serial killer, you are throwing it with an initial velocity of 20 ms minus 1. Now you have to find when reaching his head, or when reaching the ground, what is the final velocity. And then from there, you can draw the, I'm telling you how to do the question, velocity time graph, and the area under the velocity time graph will give you the distance of the ball. So distance of the ball or distance of the object is equal to the height of the building, no? So see, to find the height of the building, you have to do such a thing. Okay, first find the final velocity, then draw a rough graph, and then get the area under the graph. That will give you the distance of the ball. Finally mention that distance of the ball or distance of the object is equal to the height of the building. Okay, and that is equal to the height of the building. So what we can say is time is equal to 4 seconds. Yes, can you all try this? I'll give you all 5 minutes. Can you all try this, please? This is the trapezium related question many were asking. Okay, some have got the answers, but some are wrong. Shall we discuss this? Because I have to finish before 11. I'm having a grade 9 session at 11. So, Puta, first thing is we have to find the final velocity. Here, what is the acceleration? Gravitational acceleration, no? 10 ms minus 2. Then can you all remember acceleration equation? So you have the initial velocity, you have the acceleration value, you have the time. You have to find the final velocity. So you can use this equation, A equals V minus U over T. What is A? 10. Acceleration is gravitational acceleration. Initial final velocity, we don't know. We need to find that. What is the initial velocity? How much did I throw that object with? 20. Divided by the time, 4 seconds. So then Puta, use your maths knowledge. 4 will go to the other side. 10 into 4 is 40. 40 equals V minus 20. Minus 20 when going to the other side will become plus 20. So 60 equals V. So what about the final velocity? 60 ms minus 1. Did you understand this?
So should we find the distance also for this?
Yeah, we have to find the distance. Distance is equal to the what? Height of the building, or else we can't find the height of the building, no? You're finding distance is the final part. Okay, then we found the final velocity, no? Now we'll draw a rough graph. From the graph only we are getting everything. What graph? Velocity time graph. We are going to draw a velocity time graph. Velocity time graph. Okay. Starts with 0 time and ends at 4 seconds. Within 4 seconds, this is happening. But what about the starting velocity? Is it starting from 0?
No.
No, it's
20.
starting from 20. And ending at
60.
60. Ending at 60. So starting point is here, ending point is here. So I am taking the graph like this. Now Puta, from the velocity time graph, what can we find?
40
This
meters,
is
40 meters is
the
this.
displacement.
Yeah, the distance or the displacement can be found, no? So area under the graph is equal to the distance. So how to find the area? You can do it in 2 methods. You can break this question into 2. Break this diagram into 2. Rectangle lekai, triangle lekai. You find the area of the rectangle separately. Find the area of the triangle separately. Then you will get the total area. Or else use the trapezium method. What is the trapezium method? You take this part as the upper part, 20. This part as the lower part, kiyada, plus 60. Whole thing divided by 2 multiplied by the height. Okay, rotate the phone and see. It looks like a trapezium, no? Rotate the phone and see. So height is, according to maths, we call this as the height, no? Into 4. So 20 plus 60 is 80. 80 divided by 2 is 40. 40 into 4 is 160 meters. Did anyone of y'all get this answer? How many of y'all got this answer? Good. Anyone else? Yeah. Now, Puta, you all can try. And in my paper classes, I'll be giving more questions related to this. Once I finish this with my physical class students. Okay, I have more questions here. We have more, but no time to finish everything. So one by one, Inshallah. We'll do the remaining parts in our after Ramadan paper classes will start. Grade 10s, it will be a free paper class twice a month. So we'll be doing all those things. So I hope you all understood clearly about the 12 graphs present in your syllabus. So Buddha, please do the writing because I didn't give you all anything to write to save the time. So please do the writing and then be ready in our upcoming classes. We will be discussing more. So as a help, I want all of you all to share about the classes to your friends. Okay, especially online students. Okay, we are having the classes on Sunday. This Sunday we don't have the class, but the upcoming Sundays we will be having the classes. So in the group, I will be putting a poster. You all can share that with your friends. Okay, so our paper classes will be started in the near future in April. Soon after the Ramadan festivals, we will be starting the paper classes. So grade 11s, all 4 weeks will be having paper classes. Grade 10s, twice a month you will be having. So per month you will be having 2 free paper classes. So join that in that we are going to discuss more and more questions because now you can understand physics is related to questions. To understand physics properly, you have to do the questions properly. Okay, so just memorizing theory is not enough. You'll have to do questions and understand the concepts. So I hope I have made everything easy by giving you all the 12 graphs in one page so that you know these are the things which are in the syllabus. So according to that, you can study further. So the ones who are coming to our theory classes, we will be discussing about this more detailedly because today I was totally growing with the graphs now. So the theory part also related to the graphs, we will be discussing that. Almost everything is done, but further we'll have to do more questions to make sure that you have understood everything completely and clearly. Okay then students, thank you for joining the online session in this Poya holiday. I hope
Thank you, sir. God bless you, sir.
okay, welcome. I hope you all will inform your friends also
Sir,
and bring them to the class. Yes, Puta, any doubts with this?
when you will start the grade 10 class at 10 to 12?
Yeah, we are starting from yeah, actually it's like this. On the 9th, I'm unable to have the online class, so I'll have it on the 10th. Then 10th will be a Monday. Then Monday, I think you all can come. Then from there onwards, all the Sundays, from there onwards, it will be from 10 to 12. Grade 10 classes from 10 to 12. This is mainly for
Okay,
the
sir.
online. Okay, mainly for the online. So physical class students, if you all have any problems or any issues, you all can send me a WhatsApp message. Whenever you're messaging, you put your name and mention whether you're from Master Academy Kolonnava, Brightex Dehiwala, or whether you're from online. So then I can quickly answer it because some students say, sir, can you send me the timetable? So then I have to ask which institute are you from? Are you from Colombo, out of Colombo, like that question. So to make it easy, you all send me the details. I can reply to you very easily and quickly. Okay, then I have to start my grade 9 seminar session. We are doing the I lesson. So you all don't need that thing, mainly for grade 9s. So all the very best. Inshallah, we'll meet you in the upcoming theory and paper classes. Assalamu alaikum and good day to all of you all. I will end the session now. Okay.
Waalaikumsalam, sir. Waalaikumsalam, sir.